So welcome back. So let's finish on this. So as I was saying, so you basically use what's called the scientific notation, as you probably know it in base 10. You can write any number in that way as a number between 1 and 10 excluded times the power of 10. The same thing applies in base 2. You can write any number as a number between 1 included and 2 excluded times the power of 2, right? So the standard that's typically used, I think, is with the powers of 2 because it's more space efficient, but there also exists another one using powers of 10. But anyway, what is right here is only a human pedagogical way of telling that. So this is why I'm using the powers of 10. It's just to tell you that if you use this one on 32 bits, typically called float in many languages, you have 7 digits of precisions, and you can express anything between 10 to minus 37 and 10 plus 37. If you use the 64 bits, which is more modern, you have a precision of 15 digits. After 15 digits, it gets cut off. And here you see, you can have much, much larger numbers of powers of 10 there. So that's called single precision, 32 bits, double precision on 64 bits.
We have a question, clarify the difference between numeric 32 and decimal 32.
There is none. This is just synonyms. Just like for character, char, character varying, varchar, these are just synonyms. It's like I said on Swiss German, right? You can say the same thing in many different ways depending on the village in which you live. All right. So don't worry. It's just 2 different synonyms. Okay. So this is the numbers. Now I wanted to come back because we actually, or more precisely, Andrea did a bit of investigation during the break. Let's maybe start with the strings. When was that? Right here. Yeah. So what happens is that indeed we tried, and it seems that the spaces go away. So it seems to actually ignore spaces at the end, even though in the memory they are actually there. But we notice that the documentation does not match the behavior. So what it says in the documentation of PostgreSQL would indicate that it should be like that. And if you try it out, actually, you just see the F, but you will not see the 2 spaces. So these are part of these implementation details. It's always a good idea to try that out, right? Yeah, I'm sorry we don't have a better answer because basically the best I can say is that it's a bit fishy in there, in the implementation / documentation. But the most important part is that you understand what these types do in terms of domain, right? What is and what is not a char3, a varchar 5, and text. Who understands this on the big lines? Yes, go ahead. Maybe the catch box.
Hello? Okay. Is a space defined as a character that can be truncated? Because in this case, in the most lower case of the middle column, you see that the 5 spaces were truncated after 5. So there is a way that says the character for a space can be truncated, but it's the only one. Okay.
This is a bit the idea. So technically, if you talk about Unicode, space is just a character like any other. It's the character number 22, right? So it's a character like any other. What happens here with PostgreSQL is that PostgreSQL actually treats spaces in a different way than other characters. When it sees a space, it's going to not throw an error, it's just going to silently remove spaces, right? But if it's a non-space, then it's going to throw an error. What happens with char3 is that if you try to insert spaces, it seems to even crash. So Andrea managed to crash PostgreSQL by trying to add a string with spaces at the end to char3. So you see, it's something that it doesn't expect. But if you think of it, that's also not the sort of things you will do. If somebody uses PostgreSQL and says char3, it's probably not with the intent of putting spaces in there. Right, if you think of these country codes. Yes? I thought you had a question. Yeah? All right. Otherwise, we continue. I don't think there was any question. That's all good. I made that's my mistake. Sorry, I didn't want to make anybody uncomfortable. All right. And for the numbers, we actually tried I told you that I didn't know this. We tried it. So if you try to insert 3141.5 in a numeric 3, where you only have 3 of precision, it's actually going to reject it. So I was wondering, will it just replace the 1.5 with a 0? But no, it rejects it. So what happens there is an error if you try to do that, right? It only truncates what's after the decimal periods. Okay. Okay, so now to finish on the types, it's also a bit, I'm not going to say a bit of a mess, but let's say there's a lot of synonyms again and a lot of types again. But basically, if you use this 32-bit one, so the one on the left, you can either say real or float 24, and double precision is double precision. It's really literally written double precision, or float 53. You can, in fact, change the parameter in there. What is this parameter here? I think it's the length in bits of that part that you can control. In this, how many bits can you have in the part of the number that is here? How many bits do you allow for that? However, let me go back. What it's actually going to do is mostly ignore what you put there. Anything between 1 and 24 is going to just map to the single precision, and anything between 25 and 53 is going to map to double precision. So actually, I'm not even sure why they actually included that in the language, because anyway, it's going to map, in the case of PostgreSQL, at least to one of the two. Okay. Just in case, for those who know Java, C++, and so on, typically in these languages, this is called float, and this is called double. Who heard of these types, float and double, right? So this is basically it. This is float, this is double. It's just that it's called differently. Okay. Something more in floats and doubles, in this arbitrary precision, is that we also have a special value that's called minus infinity, and another one that is plus infinity, and another one that means, does anybody know what that means? NaN? Yes? Not a number exactly. For example, if you divide by 0, you will typically get that. So it's not a number. You might have a bit of different behavior. So technically, IEEE 754, this is the name of the standard for this. That's called IEEE 754. The standard also specifies how they compare. So normally, if you have a not a number and a not a number, and you try to compare them, you should normally always get the answer that they are different. But in the case of SQL, they compare actually equal to itself. So if you have none and none, then it's just going to compare as true for equality. So you see, there's a bit of slight differences of behavior there. All right. Okay, that sounds complex, right? Because there's a lot of numbers, a lot of types, a lot of synonyms. But hopefully, for all of you who speak Swiss German, you probably already have this feeling when you talk with people from other villages and cities, right? So this is really the same, a bit the way to look at how SQL implementations actually work. So in practice, what people do is, when you learn with PostgreSQL, and if you don't know, then you will look it up in the documentation, right? So typically the developers or data scientists, they have a window open with the PostgreSQL documentation, and they just look for what they need. In fact, I remember that that actually happened in this lecture 2 years ago. While I was giving the lecture, half of the class had the PostgreSQL documentation open on their laptops, and were fixing my slides live, which was awesome, because then we completely synchronized it with everything that I had overlooked. All right. So now the Booleans. This is easy. There's 2 Booleans, true and false. Now, if you want to input them, there's a bit of flexibility, because you can say T, true, Y, yes, on, 1. All of that is accepted as a lexical value. Remember the lexical values? It's also for Booleans. So all of that counts as true. And false, F, false, N, no, off, 0. All of that is accepted as false. But be careful, because a lot of that is non-standard. That's specific to PostgreSQL, but in the SQL standard, that might actually not work in that way. So the regular way is TRUE in uppercase and FALSE also in uppercase. So I have to add now that SQL has a peculiarity, which is to use what is called three-valued logic. Most of you probably learned logic with true and false, right? The truth tables, and, or, not, and so on. There's either it's true or it's false. Either it's raining or it's not raining. But in the database world, we have a third value that is often called null. It can also be called unknown, depending on the environment. But there is a third one. This third value is a bit special, can mean different things, can mean that you do not know or you're not allowed to know the value. In fact, it's not only for booleans, it can be for many other types as well, as we will see. So this is what you should know. I'll come back on that in 2 weeks when we start doing actually Boolean logic, but you should know that null is also a third possible value in there. Okay, now I have good news for you. For Booleans, it's easy. There's only one type, it's called Boolean, and that's it, right? So probably this should not confuse you too much. All right, the next types we have to do with dates and times. Dates and times are very often overlooked in many products because people focus on numbers and strings and booleans and so on, and they forget the dates. But the thing is, anybody who worked in a company knows how dates and times are actually super important, and you should never neglect them. So this is why in databases we have them. We have dates and timestamps. So the idea of a date, so typically in databases, you have the Gregorian calendar with the year, the month, and the day. Of course, there's plenty of other calendars around that are still in existence today, and there are also database products that even allow you to switch or use different calendars, right? But typically, this is the one that is probably the most widely used. Then we have times, hours, minutes, seconds, right? This is easy. I assume I don't have to explain much here, right? So you have hours, minutes, seconds in the base 60. The word I think is sexagesimal, if I'm correct. So that basically means base 60. It allows also for up to the microseconds. So you see there's a decimal period in the seconds, all the way milliseconds, microseconds. So you have 6 decimals in many database systems after the decimal periods. So this is the dates, these are the times, and you can have also what's called a timestamp, which is the date plus the time. So a specific point in time, a snapshot, where you have the year, the month, the day, the hours, the minutes, the seconds, all the way to the microseconds. All right? Now I'm throwing that at you, and again, I know that's a lot of synonyms, a lot of ways of doing that, but you have to focus on the main idea, right, of what is done here. So first, you have the type date for year, month, day. For times, you can specify the precision of the seconds. This means you have 3 digits after the comma for the seconds, so up to milliseconds. Now there is an additional thing that you can configure is whether or not you allow for a time zone. Do you just say, it's today 10:15, or do you say it's 10:15 Central European time, or even CEST? Right now, we are still on summer time. So you even have the choice of with or without the time zone. That also can be convenient in a company, because then you don't need to think too much about time zones because the database takes care of them. And the same goes with the timestamps. You can have a point in time right there with or without time zone. And here also that controls the number of value of digits after the comma for the seconds. So this is up to the microseconds, and here it would be the 10th of milliseconds. All right. Okay, so this is basically what types are going to look like. If you do without time zone, it doesn't mean there's no time zone. It probably means it's implicit, right? If you are a company and you work just in Switzerland, for example, then maybe you don't need to use time zones. It's just the Swiss time. Right? You have questions? No questions on Zoom? All right. I feel, every time I show you a slide like that, I feel bad because I'm throwing all of that at you and all these types and so on. But really, I hope that you get the big picture of things, right? So it's basically like being in a restaurant and you're given a menu and you can pick from the menu. The types are exactly like that. You have a big menu with all of the types that are available in PostgreSQL, and all you need to do is pick your types and use these types in order to define your tables. All right. Next, you have durations. For example, a duration of 2 years and 4 months, or a duration of 3 hours and 14 minutes, right? These are examples of duration. So it's not like a snapshot in time, it's a duration in time. Can anybody tell me why right here I have this line between months and days? Yes, maybe the catch box.
Maybe it's because those are kind of unique values. So like there's only one July of 2022, but the days, hours, minutes, etc., they repeat each day again.
Almost. So I think you could argue, right, that the first repeats also every month and July repeats every year, right? In the same way, trying to think out loud. Let me think.
Months have different numbers of days.
Sorry?
Different months have different numbers of days.
Yes, this is the I think this is the answer I was. But I was also thinking on what you said, whether there is a difference between day, hours, minutes, seconds, and year, month also in that sense. I think yes, the first repeats every month, July repeats every year, and the time repeats every day. So I would think that there is no difference like that. Do you agree with that? Or yeah, you agree. And then coming to your answer, so yes, this is correct. Indeed, if you ask how many months in a year, 12. How many minutes in an hour, 60. How many seconds in a minute, 60. But how many days in a month, 30, 31, 28, 29. This is the idea, right? So you basically have an ambiguity right here, and that's the duration wall, right? Okay. All right. By the way, I really want to say, when I ask questions, and you don't necessarily give the answer that I expect, maybe also that's an answer I did not anticipate, and that is the correct one. Sometimes the answer can be a mistake. You're safe here. We are safe. We are in a university. We are learning things. I make mistakes too, and it's fine to make mistakes. You know, it's exactly how you learn. In fact, for example, when you learn languages, there's a reason why children are much faster than we are adults at learning languages, is that when children speak, they are not afraid of making grammatical mistakes. You know, they just speak and the flow comes out. As an adult, when we learn a language, we focus a lot on the grammar and getting the sentence correct. And so we block ourselves, you know, for fear of making an incorrect sentence. But for learning, making mistakes is actually very important. This is exactly how you learn. And there is a professor at ETH, he's called Manu Kapoor, who is calling that productive failure. And he had many studies that show that not hesitating to give answers to questions, whether they are right or wrong, it accelerates the learning, because this is how you get a feedback loop in the brain. So I really wanted to say, never be afraid of giving answers to my questions. And even if these are not the expected answers or wrong answer, this is totally fine, because this is how we learn. I just wanted to make sure to make that clear, that you really do not hesitate to participate. All right. Okay, so now I'm throwing yet another one of these slides at you with plenty of these things. So these are the SQL types with intervals. So the 3 here is again the precision during the seconds, so I have 3 decimals after the decimal period. And then you can say, for example, year, month, or year, month, day, and so on. So you can specify exactly where you want to go. Hour to minute, for example, would be 1 hour and 13 minutes, and so on. For whom is that clear? What this does? Okay, these are all the kinds of duration. All right, next we have binary values. What if you want to store a picture in there? Actually, I'm pretty sure WordPress does that sort of things. If you try to upload pictures in your blog, it it will probably have columns where you can upload binaries. So this can be a picture, a video, audio, or whatever. It's basically a value that is made of zeros and ones. And that's it, a PDF, music, yeah. All right, so for binary, it's very close to strings, in fact, except that strings would be sequences of characters, binary would be a sequence of bits. So we have this binary 10, which is the fixed length, exactly 10 bits. Var binary is to be compared to varchar. So varchar has 100 bits tops. And then variable length without limits. You remember club, character, large object. Here it's blob, binary, large object. And byte A would be a non-standard way. It's like text for strings. But I think in PostgreSQL, a lot of people say byte A. Somehow I think this is the one that's popular. And also text would be used for strings. Okay, so these are the types. Okay, what do we have here? Well, there are so many that I threw at you, so many types and so many full pages of synonyms and so on, that I felt like I had to summarize it somehow, to basically have some place where I put the most important ones that you really should remember. And so this is what I did here, right? So char, varchar, club. I try to insist on the standard ones, binary, var binary, blob, numeric, decimal, small int, integer, big int, remember, depending on the 32, 64, float, real and double precision, the equivalent of float and double in programming languages, booleans, date, time with time zone, timestamp, time zone with time zone. And typically for intervals, there are two that are very popular. It's year to month or year to day, and it's day to seconds that are the most common ones. Okay, we're actually done with the types. So I threw a lot of that at you, but this is really the main message is there's plenty of types all over the place, and there is surely for every one of your use cases, one of these types that is what you are looking for in order to build your database, right? Any questions so far? Who is following? Who is on top of things? Okay, very good. Do not hesitate to interrupt if there is anything. Now we're going to switch back to, again, something a bit easier, right? And with less of these big lists. So now that we have this restaurant menu, we're going to place the orders. And speaking of restaurants, I wanted to give you this analogy that I made during the break when somebody was asking, what does it mean that SQL is a declarative language? The difference is when you go to the Mensa and you ask for the veggie menu, this is declarative. The cooking, either you cook at home or the team of the Mensa cooks in the background, this is imperative. This is actually how you do it. In fact, a relational database product like PostgreSQL gives you SQL to interact with as a user, but it is implemented in an imperative language, probably C++, Java, I'm not sure exactly which one, Python, but in the end, it is an imperative language because this is how you communicate with the computer. What's important is that the database management system is going to hide that imperative language from you so that you can use a declarative language on top. Okay. So what are we going to do? We are going to see how we create tables in SQL, how we modify tables in SQL, and to, for example, adding values, populating values, and we are going to drop tables in SQL. So that's what we are going to do next. All right, again, remember that we have sets of maps, we have attributes, and we have the domain. And this is actually important because when we use PostgreSQL, we have to specify the domains, right? Okay. So when you create a table in PostgreSQL, it's going to be empty. What you specify is the attributes of the tables and the domains that these attributes have. So all we need is the name of the table, the attributes, and the associated domains. Here you go. This here is SQL. It says create table, hello world table. That's whatever name I actually came up with, maybe not very original. Then name, that would be my attributes, and text, that would be the type. All right? So how many rows and how many columns after that will I have? How many rows, how many columns? Maybe on Zoom otherwise. Zero, so 0 rows or zero columns? I see 1 column, 0 rows here. Do you agree?
Yes, 1 column, 0 rows.
Yes, exactly. 1 column, 0 rows. 1 column called name and 0 rows, that's because of what I said here, that it's empty when you create it. So indeed, 1 column, 0 rows. So the way I'm going to draw things, it's that usually I'm going to have the name of the table on top on a black background. Then I'm going to have the name of the column and then the domain below the attributes. But these are not records. This is really just the header of the table and it's empty, right? So there is absolutely nothing there. It's empty, but there is 1 column. Okay. What about more columns? Let's create a table with more columns. This is what it looks like. So again, create table. I have the name of my table right there. It's called persons. And now I have 1, 2, 3, 4, 5, 6 columns. And these are the types. Do you remember them? These are taken from the menu that I gave you, right? Varchar, char, text, date, boolean, by date. You can pick any of these, right? And put them here. So you see attributes, the domain, comma, attribute the domain, comma, attribute the domain, comma, attribute the domain, comma, attribute the domain, comma, and so on and so on. Okay. This creates a table with 6 columns and how many rows? 0. Okay. Here it is. So this is persons, that's the name of the table. First name, middle name, last name, these are all the attributes. Birth date, scientist, passport scan, this is my picture. Varchar, char, text, so these are the domains here. Right, so it's empty for now, but I have my 6 columns right there. Right, this should be easy, right? This is really just creating a table. This here is something you can literally write in your Jupyter notebook in the exercise. You can write that, press enter, and it's going to create the table for you in the background, like magic. Okay. Now, if there are mathematicians, you know that when we talk about vector spaces, we also need to consider the case of a vector space with dimension 0, and so on. So it's probably the same if you want to explore the corner cases. Can I create a table with no columns? Yes, but it's not going to go very far. You could maybe create a table with 0 columns if you have the intent of adding columns later, right? But in the theory, I mean, you can absolutely have a relational table with 0 columns according to our definition. It's just a set of maps that don't map anything. Okay. Okay, so if we want now to drop a table that we created, that's easier. It's always easier to break things than to build things, right? So if we drop a table, we just specify the name. So here's the table, and there it goes, right? So all we do is drop table, hello world table, and that throws it away. What if you try to drop a table that doesn't exist? That's going to throw an error. It's going to complain that the table doesn't exist. So that's actually very annoying because when you have scripts, and that actually includes the exam, what we use in the exam to pre-populate the database that you will use, we have a script. That script creates the tables, creates the columns, creates the types, and populates it with data. So normally you press a button, it executes the script, and then creates everything. This script begins with create table. So you execute it once, and then you have the table populated. But what if you press again? Then you're going to have an error. Imagine you update the script in order to add different values or change a schema. It's going to throw an error. Why? Because the table already exists. So what you do is then you add drop tables, right? You first drop the tables, then you create the tables, and so on. So that solves the problem of iteratively re-executing the script. But you still have a problem. It's the first time you execute the scripts, and it starts with drop tables, but they don't exist yet because it's the first time. We have something really cool for that. It's called drop table if exists. This is what we actually love to use in scripts. So drop table if exists, and this is going to drop it if it exists. And if it doesn't, it's not complaining. You don't get an error. right? So this is really, I would say it's more of a practical thing for database administrators that they can do that. Okay, who is on top of things with creating tables? Can you create your own tables? Who can do that? All right, perfect. So great, we learned something. The next step is to populate the tables. Let's start adding records to the table. So we'll learn how to insert a tuple or a record or a map or whatever you call it. We are going to see how we update them, and we are going to see how we delete them. This is how you insert a record or a tuple. Insert into hello world table, values, Einstein. How many columns and how many rows will I have after that? One and one. There you go. Right. One each. Exactly. Okay. What about that? There's no trap. 1 and 2, right? So Einstein and Gödel. All right. What's the difference between the two? The only difference is that here, I didn't just say the name of the table, I also specified the column. So you may think, okay, that's useless, there's only one and so on, right? But you will soon understand why it can actually be useful to specify the columns that you want to add your values to. So 2 rows and still 1 column. Now, here, more complex, I picked that table of earlier with my 6 columns right there, and I'm going to add 2 rows at the same time in a single comment. So insert into persons, that's the name of my table, values, and here I put my list, right? So James T. Kirk, date, blah, 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 false. And this is a fancy way of putting binary with encoding it you know, with some hexadecimal characters. So don't worry too much about that. Then a comma, and then my second row. So then I get a table with 6 columns and 2 rows, and here you have, you see, the extension of the table. Okay. So far, so good, right? Now, I can also specify my columns, as I said, insert into persons with the names of my columns, first name, birth date, scientist, passport scan. What did I do here? I left out the middle name and the last name, right? So I'm just saying, okay, Spock, you know who Spock is, right? 2230, true, and here's the picture, and there you go. What happened here? We did not give any middle name and last name to Spock, right? So what that means is we have Spock, we have the other values there because we specified the columns, so it knows exactly where to add these values. But here we add a null. Where did we see the nulls? We saw the nulls when I told you about booleans. Booleans, true, false, or null. In fact, you can also have nulls for any other types. You can always have places in the tables that use null. By default, this is something I didn't tell you in the theory. Why? Because in the theory, I said it's a set of maps. And if you don't care about the constraints, you could have empty places, right? You just have a map that doesn't map an attribute. But the thing is, I also told you we have the relational integrity, and all the columns should be there in every map. So it seems that it doesn't allow for nulls or for missing values. So you have 2 ways of doing that, or of dealing with that. Either you say we relax relational integrity a little bit, and we allow for some of the maps to miss attributes, right? So we relax that a little bit, or we add null as a specific value to all of the domains. This is the second way of doing that. It's kind of equivalent, but you can still do it in these 2 ways. But what does it mean for a value to be null or missing? It can be that you don't know what the value is, so you just leave it out. It might be that it's not applicable, for example, for Spock, it's not applicable, or it might be that it's secret. You're not allowed to actually know that value, or you don't have access to it. So a user who doesn't have the credentials might see nulls at all the places that they are not supposed to see, right? Can we control whether or not we allow for that? What if we want to strictly enforce relational integrity and we want to strictly forbid to have nulls? Well, we can do that. And the way you do that is to add not null. So right after, you see you have the attributes, you have the domain, and then you say not null. This is going to forbid having empty or null values. You can also say null explicitly, but this is useless because that's the default. If you don't say anything, by default, it's going to allow adding nulls, right? So this is the default. Okay, so let's say, okay, we allow null for middle initial and last name because this is what we're missing for Spock. And we have here we don't allow nulls at other places. It's good practice, at least at first, to try to disallow them, to force the values to be there, especially for machine learning, can be very tricky if you have nulls in your feature columns. So it's a good practice to try to restrict, right? And at the places that you don't mind, then you can allow for the nulls. Okay. Now, let's look into how to update tuples. What if we want to change the content of a table instead of just adding something? Well, I can say update persons, set the last name to Picard where the last name was Crusher. So Beverly Crusher, she is right here, becomes Beverly Picard. So you make that update. The where identifies this record right here, the second one, and you set the last name right here to Picard. This is going, can we make that disappear on the screen? It's exactly on top. Yeah, I never fully figured out how Zoom allows you to remove the control bar. Actually, somehow sometimes it's still keeping it. But anyway, you understand what happens, right? In the lecture hall. So we basically change the value right here, and after this update, we have the last name set to Picard. All right. The next thing we can do is remove records, remove tuples. Delete from persons where first name is Spock is going to just remove. There were 3 rows and now there's only 2 rows left, right? Okay. Who is following? Very good. This is easier, right, than when I was throwing these lists of types at you. Okay, now default values. It is also possible here. Is there a question on Zoom?
There's a suggestion that if you open the chat and then close it, the bottom bar disappears, apparently.
If you open the
Chat.
Oh, the chat. Oh, wow. Open the chat and I close the chat. Oh, yeah, it worked. Sorry. It feels like Windows. You know, you just need to click at exactly the right places for a thing to magically work in some way. All right. So now you see what was going on. So here you see, thank you for that. So you see the change right here. And now you see there were 3 rows and there were 2 rows right there. Okay.
Another question, if there are multiple people named Cracker, does it replace the name for all of them?
I think so. We can. You think so too?
Yeah.
Yeah. Okay. So we are two to think that yes, it will actually modify all of them. Right. We'll look again at the where clause very soon when we query. There is the notion of highly filtering queries that very specifically identify one row with the where clause, and there are some that are more loosely filtering, where you can actually have 10 or 100 rows that are captured by the where clause. All right, thank you for the question. Okay. So what happens if I insert tuples, but I don't want nulls in the missing columns? I want default values. What if I want my middle name to be n by default and the last name to be none? Well, now, if you defined it that way, and you try to insert, now so I need to use that trick. It's really an awesome trick. Open the chat and close the chat, and there you go. So now you see I don't have nulls anymore. In the columns that I didn't specify here, middle name, last name, now I have n and none, right? It's magic. That's the power of a relational database system. It does it for you. Okay. You can, of course, have both a default value and a null. You can even say the default is null. Actually, by default, let me put it that way. The default is null. If you don't specify any default, then by default, null will be used. All right, I hope that I was clear. Okay. I can do two things. I can tell you a few more things, or we call it a day. I let you go to the Mensa. Let's vote. Who wants to go to the Mensa? Some of you, or you're too shy to say. Who wants to continue for a few minutes? Oh, we have more people. Okay, let's respect the majority. So let's now try to modify the tables. Add a column is done using this alter table statement. You have create table, you have drop table, so alter table, hello world table, add column, flag, boolean. What you put here is exactly the same thing that you had on your schema, in here. That's exactly the same thing, the same syntax that you have here is also what you say after add column. The attribute name, the type, the default value, and null or not null, right? So that is going to modify the table and add a column right here. You can also specify, as I said, that it's null and the default is true, which is a boolean. Okay, next, let's rename the column. Let's say we change flag to F. That's how you do it. Alter table, hello world table, rename column, flag to F. Okay. You can also drop a column if you want to get rid of that column. You have one less. Okay. So you can do all of this with instructions called alter table, and you can also rename the entire table, not just a column, but hello world table. You can change it to, let's say, table in that way. Right? So this is what the alter table command is doing, right? So we learned one more thing. I will now just check that you followed what I told you. I really hope I didn't scare you with these huge lists of types that can be different between implementation. This is usually a scary part of that lecture. But I hope that the part after that, when we created the table, you found to be much easier once you had the restaurant menu in place. So let's see where you are. Oh, people understood everything. That's awesome. And nobody so far is below 80%. This was then an easy day, right? This is really good.
While folks are voting, what happens with the entries we already had in hello world table when we set the flag to not now? We don't have any information regarding it. So setting a table to not now where there are nouns. Sorry, setting a column to not now when there are nouns in the column.
Let's do it offline because now I have my doubts that the documentation is the same. We'll try it out together, and then we'll give you an answer next week. Or you can even try if you want, but we'll begin with that maybe next week. Yeah. Okay. Wow, this is awesome. I didn't expect so many people above 80%. This is marvelous. Okay, so I will let you go. Thank you very much for attending today's lecture. Thank you for participating. I also learned a few things along the way today. That's really great. Enjoy your meal, and I'll see you next week for yet another lecture, finishing that, and then theory again with the relational algebra. Have a nice weekend. Thank you.